2 minutes, everyone, just to try the question that I have on the screen. Solve for x if I've got x plus 2 over x minus 3 is equal to x plus 8 over x plus 4. I'm going to tell you right now, because I've got two fractions and they're already factorized for me, normally I'm going to have to look. Is your two, ladies and gentlemen, take it away. Let me know if you have an answer in the chat. Remember, normally the ones that we're doing these days are usually either linear fractions of fractional equations, or they are the other one called quadratic equations. Oh my goodness. See, guys, I missed one lesson on Wednesday and my brain is already complete. All right. Okay, so it's probably going to be either linear or quadratic. So I'm waiting to see if anybody's got an answer for me. If we're looking for our LCD, remember, if I had 1 over 3, or 1 over 3, to find my LCD, I would just take this one and this one, and then I'll figure out which one is missing on which. All right, so 1 more minute, everyone. Tell me if you do find it out. Okay, in the meantime, if you are new, could I ask you to drop a hi, I'm new in the chat. You can put your hand up so we can give you a nice big fat Watobe welcome, so we can meet you if you're joining us for the first time. Unami is joining us for the first time. Hello.
Ooh, welcome to Watobe.
Welcome. We're so happy to have you with us. You'll see we're a whole vibe. I have a feeling there's some people who I have not met who came on Wednesday, so it would be welcome. Welcome. It would be amazing to meet you guys. Raliboka's got her hand up. Olerato as well. Zime is new. I'm hoping I said that correctly as well. Zime, welcome. Kayusha, I hope I said that correctly. Kayusha, welcome. I'm so glad to have you with us. And you'll see that our wonderful Watobians will always say hi to you. Hello, Funzo. It's so great to see you again. If you are new, I can tell that Amukalang was new as well. Hello, Amukalang and Mom. I see you guys there on the camera. Welcome. Awesome to have you guys join us. Unse is new as well. Don, don't try me. Don is part of the furniture. Don't let Don lie to you. It's been here a while. Mange, very nice to have you with us. It's amazing to see you guys with us. If you are with us for the first time and you're a little bit lost as to what's happening, we are doing an example on the screen as we get started. Shaden, you too. Oh, Stacey, you know I love you guys. All of you guys who've been with me from the beginning. I love you guys. I'm glad to have you. So you don't have to be new. You're like part of my heart ventricle. All right, let's have a look at this question quickly. Does anybody want to pop what my LCD will be? Anybody want to tell me what my LCD is? Remember, we're just going to take the two things and we're going to multiply them together. You don't even have to spoil out. You don't even have to spoil out. I see what Nobuche has done there. Nobuche has taken just the numbers, multiplied them together, and that's not what we want to do in this case. What we want to do, we want to take the whole thing, multiply them together, just like Muteo has done. Muteo, you're a whole genius. Thank you very much. So we're going to take both of those, and we're going to multiply them together. And we don't even have to do that whole x times x, x times 4. No, we don't. I'm going to draw this on each side. Minus 3 multiplied with 4. Going to be equal to something on this side, also multiplied by x minus 3. All right. The best thing, guys, the most wonderful thing about equations that are fractions is as soon as we have an equivalency of denominators on both sides, we can drop the denominator. So we just need to figure out what's missing on the top. All right. So, guys, have a look at this part of my denominator. And then look at this part of my denominator. I only have x minus 3 on this part of my denominator. So what's missing over here? You guys can put this in the chat for me quickly. I want this to look like this denominator. I want this one to look like that one. which part of my denominator is missing? Let me know, guys, in the chat. Anybody got an idea? I want them to look identical, the bottom and the what's missing from the top. That's it from Vaughn. Thank you, Vaughn. That's it. The x plus 4 is missing. And if you know anything about the rules of fractions, what I do to the bottom, I'm going to have to make sure I do as well. So if I multiply by x plus 4 on the top, then on the bottom, I'm going to have to multiply by 4. And I see some people saying, ma'am, your sound. Can I just get a thumbs up in the chat from everybody who can hear me? Just put your reactions in. You can click on the emoji part and show me if you can actually hear me. Or just write, yes, ma'am, I can hear you in the chat if you're not okay with the sound. Okay, so I can already see that there are a couple of people who can't hear me. Thank you, Relevo. Ayanda can't hear me. Joanna can't hear me. All right, and we're going to solve for that in just a second. Same page. And thank you. Thank you, Lucero. Melissa says, I'm lagging. Can you just let me know? Am I lagging? Maybe I'm lagging and that's the issue that's happening.
No.
Okay. All right. No, like internet and things is very weird these days. So I'm just going to put this over my face, just make sure. It really is. All of this comes from the other day. I don't know what I do now. That's what I do. It's okay. Okay. And I need to not do that. Okay. I'm going to put this over here. For any of you struggling with your sound, yeah, it's over my face. Look for this. Oh,
Is it lagging?
All right, I'm gonna have to figure out what.
How's your Wi-Fi?
My Wi-Fi is pretty strong, so I'm having a bit of trouble understanding. All right, guys. So I'm gonna switch my camera off for just a bit, and let's see if that fixes the problem. Okay, if you can't see me, I am here. You'll hear my voice. I'm just gonna try switch my camera.
Yeah, same with
everyone can draw with my vibe. All right. For those of you who said I'm lagging, give me a thumbs up if you can hear me now. Hayden says it's fine. Hi, Kumo. Says they can hear me perfectly fine. Kumo, I hope that hand up means that you can find. Okay, excellent, Keisha. Thank you so much. Pika and Funzo can hear me. Luanda can hear me as well. All right. Guys, I know that we've got like the national electricity crisis. And that normally does affect our network. So if you cannot hear me, guys, remember that all of these are recorded. And I hope you guys can catch up. X plus 9. All right. Okay. Next question. What part of my denominator is missing on this? What part of my denominator is missing over here? That's it, Funzo. Excellent. X minus 3. Minus 3. So what I do to the bottom, I'm going to do to the top as well. X minus. All right. Teacher Nels, can I ask you to help puzzle? Good. Okay, facility says 3 and 8. Okay, we need to be really careful facility because that whole thing, the whole x minus 3 and the whole x plus 8 and x minus 3 is what's missing. So we need to make sure that we put that in x plus 8. All right. So here's the nice thing about equations. As soon as my bottom, the left-hand side and the right-hand side bottom look the same, they can follow. This is not the same. It will not look the same when you do. When we have expressions, my denominator does not go away. Never ever. You need to make sure that it's still there all the way until the end. Okay. So in this case, I can drop it because it's equivalent on both sides. Okay, then it says, ma'am, I'm a bit lost. Our lowest common denominator is 12 in the brackets. Then let's say my lowest common denominator would be 12 if I had something over 3 and something over 4. I don't have 3 and 4. That's not what I have. On this side, I've got x minus 3, and over here, I've got x plus 4. Now, then it's what you're telling me is my denominator would have been 3 because I would have taken 3 and multiplied it by 4, and that would have given us 12, right? So in this case, it's not just 3 and it's not just 4. It's 6 minus 3 and it's plus 4. So my whole thing, I have to take this and multiply. I have to multiply both of them. Okay, and Zudin, I'm so happy to hear that, because that's exactly what we're starting with on Wednesday. I need you to come and help me so that we can exponent. All right, so that's going to be my denominator. And now that I've got 2 brackets on each side, I'm going to FOIL out 1, 2, 3, 4. Out, 1, 1. All of that. I'm going to get x squared plus 2x plus 4x plus 8. No matter those I. I need you to explain to me what in the world is going on that you look so confused. Okay. And then on this side, I'm going to do the same thing. Top, bottom. X squared minus 3x plus 8x. Yes, my sweet. I'm going to ask Kumo the same question in just a little bit. Hi, Numaza.
Hi, girl.
Hello.
No, ma'am. Hey. Yeah, ma'am, it's tough in the streets. Cause your side, I get guys. Oh, sorry, ma'am. So once you've multiplied out the brackets. Oh my God, these people. Once you've multiplied out the brackets, do you drop the denominator and then just add and subtract on from there?
Yes, absolutely. Okay, let me explain it this way. All right, I'm going to use simple fractions, right?
Yes,
If I
ma'am.
had, my question was x over 2 is equal to 3 over 4. What is my LCD over here?
Isn't it going to be x plus 4 into x minus 3?
Okay, LCD will be this between these.
Oh, sorry, ma'am. I thought we were talking about this. LCD is of course going to be 2. Yes, ma'am.
Remember the big number. So my LCD is going to be
Maybe 8. Oh, 4.
Yes, we can make it 8. We can make it 8.
It's been such a long day. Sorry, ma'am. It's been such a long day.
It's fine. It's fine. Even if we told it to be 8, you wouldn't be wrong. It's not the lowest common denominator, but it's a okay.
Yes, ma'am.
All right. So if my denominator is 8, on this side, I'm going to multiply by 2 to get 8. Correct?
Yes, ma'am.
And what I do on the bottom? What I do on the
you do the top, ma'am. Sorry.
So this is going to become 2. And over here, I'm going to multiply by 4.
4, ma'am.
And over here, I'm going to multiply
by 4 as well. Yes.
Good. So now the top, I've got 4 times x. That's going to give me
4x.
over.
Period.
Times 4 will give me
8.
So it's going to be 3 times 2, which is 6 over.
Yes. 8.
Over 8. Now, because they're both over 8, it doesn't matter what my denominator is. The value of x is not 10. I don't have to solve. Okay. So I know that x, 4 times x is going to equal to 6. It has nothing to do with the denominator at all. If I want an equivalence on both, I need to make sure that I'm only solving 4. So am I going to do anything with the 8 from this point on?
Nothing really except drop them because they're not important.
Exactly. So even if I continue with them, if I keep going with them, they're just going to keep adding onto my question, and they're not gonna.
Yes, ma'am.
Okay, you understand what I'm just gonna
Yes,
keep
yes, yes.
adding them with me as I go down, and they're not that important. For solving for it, they're not that important. Right. When
Okay,
we are
I
looking at
understand.
expressions, okay, so I can just stop. They don't matter. As long as they look the same, they don't. Does that make sense?
Yes, ma'am. Sorry, I'm using data, so like everything's like a bit scratchy. Load shedding.
That's okay. That's okay. All right. That's okay. All right. So what I'm going to do now is I'm
Yes, ma'am.
going to add like terms on this side.
Okay.
Okay. So I've got x squared. That's on its own. So I've got x plus 4x. That's going to give me
X plus 4x. It's gonna give me 5x, ma'am.
not x, 2x plus x.
Sorry. Oh my gosh, we're on this side. I'm so sorry. It's gonna give me 6x, ma'am. Sorry.
6x plus 8 equal to, let's get
Over here we're going to get
squared.
plus 5x. Sorry, x squared
Good.
plus 5x minus 24.
Good. All right. Okay, now remember what we said when we're solving for quadratics. We want everything to be on the
On one
left.
side.
So I'm going to take everything on this side. X
Okay.
squared plus 6x, 8
Plus
an item
8
x squared
minus 5x plus 24.
plus 3 is equal to 0. Don't forget.
Yes, ma'am. Yes.
All right. Okay. I've got quite a lot of people who have lost me. So I'm going to ask you to finish this one for me, and then we'll start talking about. Right.
Sure.
How x squared and x squared when I cancel each one.
Cancel out.
And then I've got 6x minus 5x. How much is that going to
It's
give?
gonna give me 8.
Okay, good. And then I've got x. 8 plus 24 will give me.
Yo, quick math. Go. Ooh, I don't know. I forgot. What? 32. Yes, that number.
Therefore, x is equal to, I'm going to take the 32 back over so that I can have x on its own. So x will be equal
Which
to
is gonna make it minus 32.
negative. That's the answer.
Period.
Yeah,
Okay.
that's it. You just need to follow the steps. There's nothing too difficult.
Okay. So as soon as
Okay.
the denominator is the same, we can drop it.
100.
Okay.
This is
And
the same.
only for this section.
Only for equations. Only for
Okay.
equations with an equal sign. Okay.
Okay.
In
Thank you so
between.
much.
You're very welcome. Okay. So I'm having a lot of people who cannot hear me at the moment. I'm very sorry, guys. Okay. I'm not 100% sure what to do. The connection is quite okay. Teacher Nels, can you hear me? Either
Yeah, I can hear you, but I think the sound is just bad. And it sounds like you speaking far from the microphone or something.
Is it? Okay,
Yeah.
Give me 1 second.
Yeah.
Okay, hello. Can you hear me now?
Yeah,
Is it a lot better?
it is, but now it sounds like an echo, like there's an echo.
Oh no, okay. Okay, everybody else says they can hear me a lot better.
Yeah, it's better than before. Yeah.
Is it? Okay, all right.
Yes.
Excellent, guys. I'm sorry, I think I'm using two different things. I'm using my webcam and my computer microphone, and that's not helping. So maybe that's why it was acting a bit rough. All right, for those of you who don't know what just happened now, okay, Teacher Jen does like 6 million of these with you guys on Wednesday, last week Wednesday. And unfortunately, for the sake of time, guys, we're not going to be able to go back. So we're going to do another example that kind of sort of looks like this one. And then we're going to continue because there is something else that we need to get through today. Here's the next question. I'm going to remind you guys now that this that we're looking at over here is actually, it's a recap. It's revision. We do many of these. Okay, this is all revision. If you're still struggling with these after we do this, then can I ask you guys to go watch last week's lessons? Because we do many of these, many of them. And the best part about the recordings from last week is that they're videos, so you can like fast forward and rewind and rewatch again and pause and try the question. But over here, I'm going to give you guys a chance to pause this question and look for the LCD for me. Now, the first thing I want, guys, is we need a lowest common denominator, but I'm noticing over here that I have a trinomial. Who can tell me, what am I going to do with this trinomial, guys? What's the first thing I can do with this trinomial? Who's got an idea? You can pop your answer in the chat. Shaden, you rock star. Yes, Funzo, what do you think we should do? Oh no, Funzo, don't go away. I want to hear your voice. Okay, yes, everybody's 100% correct. We're going to factorize. Okay, so I'm going to rewrite everything else exactly the way it looks. Okay, I'm just going to write x plus 3 over x minus 2, which is equal to 2x minus 2 over, and I want you guys to factorize this bottom part for me. Right, remember it's a trinomial, so I'm going to open 2 brackets. Okay, you guys are going to tell me what goes into those 2 brackets. Once you factorize it for me, you've got 1 minute, go. Because we should be so used to it by now. And my next door neighbors are watching a very thrilling movie. I don't know what's happening over there in the Campbell teaching space. It sounds so fun. I want to go. I'm going to go check it out. I'm going to go date crush once this lesson's over. All right. Does anybody have an answer for me? Has anybody managed to factorize? Diego says x plus 7 and x minus 3. Buseleta says minus 7 minus 2. Oh, Diego says 2 instead of 3. Okay, cool. Diego, I absolutely 100% understand where you're coming from. Okay, excellent. Pila says x minus 2, x minus 7. Samkelo, I'm not sure, x minus 3 minus 7. Okay, so I can see a lot of us are getting it correct. The only thing that we're missing is our signs. Okay, and we're going to do this together. Funzo, I want you to do this with me, my sweetie. I know you're really good at these. You want to unmute for me, Funzo? Oh, yes, we can. Yes, absolutely, we can. That's true. We can. Okay, but I'm not going to do it in this case because it's not necessary. We're just going to do it again. Funzo, are you there? Okay, until Funzo unmutes for me, guys. All right, we're going to have a look at this over here. Now, remember, guys, I know that my signs, one of my signs is definitely going to be a negative. And then I know my other sign needs to match with this one. So if I have a negative, guys, and I want to get a positive, a negative times a what gives me a positive? A negative times gives me negative. A negative times a, that's it, Puselito. A negative times a negative. That means that this other sign over here needs to be negative. Okay, for those of you who gave me a plus and a minus, we need to check for this. Okay, that's how we figure out what the signs will look like. This one over here will always be one of my signs. And then I need to check if I multiply this one with that one. What do I need to multiply with this one to get that one? And a negative will give me a positive. And that's how I can figure out my signs. Okay, and then I can put an x here and an x here. And now I need factors of 14 that are going to give me 9. I know that 2 times 7 is indeed 14, and negative 2 minus 7 will give me negative 9. So I've got minus 7 minus 2. Now, if I'm going to look for my LCD, guys, I can tell that x minus 2, it's a repeated expression. So I don't have to write it twice as part of my LCD. I'm only going to write it once. So I'm going to go, I know I have x minus 2 as part of my denominator. What is the other part of my denominator, guys? What's the other part of my LCD? I've already got the, Shaden almost said common, not common brackets. Well, you could say it's a common bracket. Okay, I've got the x minus 2 itumeling. What part of my LCD is missing? Yes, Namaza.
Sure. I was actually going to ask a question, but I can try this.
Okay.
Wouldn't it be? Sorry, you asked which part of your denominator is missing, right? Ma'am, wouldn't you just make it like one thing? Well, not like one thing, but like x minus 7 and then x minus 2 and then just not include the other two.
That's it, exactly. So
Okay.
from this part, I've already written x minus 2. I'm just missing the x minus 7 part over there.
Okay.
Okay, there we go. Thank you, Palisa. I'm going to forget how to pronounce it. The Lisaro cockatoo. All right, Namaza, what's your question, my sweetie? What's up?
Sorry. So for example,
Yes.
I think, well, not in this question, but if the, what do they call it again? If the bases are similar and we've got like exponents that don't meet, could we apply the law of exponents to it?
If the bases are the same.
Yes, ma'am. So for example, 2x and 2x, but then like it was 2x cubed and then 2x, your times 2x squared. Would you be able to apply the law of exponents to it?
Of course, yes, because this one has the
Okay.
highest exponent. You're always going to take the one with the highest exponent because there already is an x inside this x cubed. Okay,
Okay.
there's an x in there, and then we just bring the 2 along because it belongs to both of them. Okay.
Yes, ma'am.
All right. So yes, in that case, we would take the one with the higher exponent. All right.
And we'd still get the same answer.
Absolutely, 100% the same answer.
Okay.
It's almost like that 2 and 4 argument we had. My LCD
Yes,
is actually 4 because 2 is contained within 4.
in 4, yes, ma'am. I hear
So
you.
there's no need for me to write 2 and 4 when 2 is already inside 4. Just like with x, there's no need for me to write x cubed times x when x is already inside x cubed. You get me?
Sorry, ma'am. Yes,
Yes.
ma'am. Yes, I do. Sorry, we just got an assignment from school today. I was just wondering if, like, by any chance we'd be doing trigonometry anytime soon.
Sure. Yes, we will be starting trigonometry. Your school is ahead of the CAPS syllabus. See, so they're quite ahead because if they're already done with this, they should literally only finish with this in 2 weeks' time and then start trigonometry. So we're still going to do exponents and then trigonometry, and that's going to hurt us a bit. But on our YouTube channel, we have many on trigonometry that we did last year. So go have a look at the channel. It's Watobe. Just go look for Watobe, look for the grade 10 playlist, and look for the sections on trigonometry, and you can start.
Oh my gosh, perfect. Thank you so much.
Okay. And if you have any questions, come see me at the end of a lesson. All right.
Yes, ma'am. Yeah, ma'am. And then on top of that, they said we're also going to be starting Euclid. I looked at them and I was like, you're crazy.
No, it's not that bad. I promise it's not that bad. It's not.
Yo,
you'll be fine, no matter.
guys, I'm scared.
You'll be fine. Don't worry. I'm here for you.
Thank you
Don't
so
worry.
much, ma'am.
Sure. All right. Njebo, I see your hand is up, my sweetie. Do you have a question or do you have an answer for me?
Yes, ma'am. I wanna ask, how is x minus 7 and LCD, the LCD of the sum?
Okay, so do you see how x minus 7 makes up part of this part of the denominator? Right?
Yes.
And then x minus 2 also makes up part of this denominator. So my LCD is actually that whole denominator, and also over here, I have x minus 2. Now that my x minus 2 is repeated, I don't have to write it twice. Okay, I only have to write it once, but I must include that whole, but I must make sure that they're all included. So Ndebo, if there was an x here, I would also have to include another x over here as part of my denominator. Okay, do you understand what I mean?
I understand.
Yes, just one of them. Okay, you don't have to include both.
Okay, thank you.
Don't go away. I know that my denominator on the side is x minus 2, x minus 7. Have a look over here, Ndebo. I've only got x minus 2, but this is my whole denominator. What's missing on this side? What's missing?
An x.
What's missing? Look, I've got x minus 2. What's still missing?
X minus 7.
Good, x minus 7 is still missing. X minus 7 is missing. So if I multiply the bottom by x minus 7, what do I need to do to the top?
Do the same with it.
Yes, I must do the same with the top. Multiply by x minus 7. Okay, so this is what I'm going to get on the top part over here. I'm going to have x minus 7 multiplied by x plus 3 is equal to, and then what's my denominator on this side? Can you tell me what's my denominator on the right-hand side?
Is x. It's bracket 7. I mean.
X minus 7. Good.
Bracket x minus 2.
X minus 2. Excellent. All right. Is there anything missing from my denominator over here, Ndebo?
No.
No. Okay. So is anything going to change on the top?
No.
No, it's not. Excellent. So I'm just going to rewrite it exactly the way it is. 2x minus 2. Okay. Now, Ndebo, tell me, do my denominators look the same on the both
Yes.
on both sides of the equal sign? So what can I do with them?
You can cancel them out.
Good, I can cancel them. I can drop them. I don't need them anymore. Tell me, what am I going to get on the top?
You're gonna have x plus 3 equal to x minus 2.
Okay, don't forget the x minus 7. It must come with us. Okay, is equal to 2x minus 2.
Okay.
All right, don't forget that x minus 7 that we multiplied with on the top. All right. Dear, well, thank you so much. I hope this makes a little bit more sense in terms of the denominator. We have to make sure everything is represented in the denominator. Do you get me?
Yes, thank you.
You're very welcome, my sweetie. Kumo, what's up, my sweetie? You want to unmute for me? Because I can see your hand is up, Kumo. Hello.
Hi, ma'am. How are you?
I'm good, thank you. How are you?
So, ma'am, every time there is the same denominator, we cancel them each other. Like, for example, x minus 2, and then on the right-hand side, we have x minus 7 and x minus 2. So we don't write the x minus 2 twice. We just write it once, and then we write the x minus 7.
Yes, absolutely. So we look at what they have in common, and then we all, if they do have something in common, we only write it once. Okay, we don't have to write it more than once. Okay,
Okay,
does that make sense?
Thank you, ma'am.
Excellent. All right, Balisa, do we have to
Yes,
make the
ma'am, it
denominators
does.
the same? Yes. Okay, yes, we absolutely have to make the denominators the same. Okay, Muteo's like, wait, why do we drop the denominators? Because once we have the same denominator, Muteo, the denominator doesn't matter. It won't change. So it's not like we've canceled it. It's kind of still there, but the equivalence is still the same. Okay, it's still kind of there. Okay, so I'm going to do the FOIL method over here. I'm going to get x squared minus 7x plus 3x minus 21 is equal to 2x minus 2. Yes, Nomaza.
Sorry, ma'am. So like, why don't we like times the x minus 2?
Mhm.
Yes, sorry, the x minus 2 by the 2x minus 2.
Oh, because it was already part of the denominator. Have a look. Okay, so here's my LCD. My LCD has an x minus 2 and an x
Okay.
minus 2. Right, and over
Yes,
here,
because there are only two
it's
denominators on the
factorized.
side.
Good. Okay, I can hear. I think that's Kumu. Do you notice how the LCD on this side already has x minus 2 and x minus 7?
Yes, girl.
There's no need for me to add another x minus 2. The x
Oh
minus
my
2.
gosh. Okay.
Okay.
No.
No need for us to do that.
Okay.
All right.
Okay.
I hope that makes sense. Excellent.
Thank you.
All right, you're very welcome, my sweetie. Nobuke says, ma'am, teacher Coco once said we cannot cancel the bottom and the bottom. Yes, Nobuke, we can't do that in an expression, okay? In an expression where we only have one denominator. But in this case, we are comparing two denominators. Okay, we are comparing because of this equal sign. Unako says, do we cancel out the top if there happens that they are the same? Yes and no. I'm going to say yes because you can do it if they're the same on each side. No, because it will confuse your grade 10 brain. And I don't want you to say that. Okay. All right, guys. I remember telling you guys, keep the denominator. Do not. Yes, I remember. That was when we had things like x squared plus 5x plus 6 over x minus x plus 2 plus x minus 3 over x squared plus 5x plus 6. Do you see how over here there's a plus in the middle? Okay, there's a plus. When there's a plus in the middle, you need to keep the LCD. You need to keep the denominator. Okay, keep the LCD. As soon as this plus changes to an equal sign, then we can drop the denominators. Okay, guys, it's not just about the fact that I said that you can't drop the LCDs. It's true, you can't drop the LCDs. But when there's an equal sign, remember, we're proving that things are equal on both sides. Okay. So it doesn't really matter how we put it. As long as there's an equal sign in the middle and not a plus or a minus, we can drop the denominator. As soon as there's a plus or a minus, keep the LCD. If there's an equal sign, don't do it. Okay, and Samkela says, do we now group the like terms? Yes, we do. I'm going to get negative 7x plus 3x is minus 4x minus 21. And then I'm going to take the 2x and I'm going to bring it over the equal sign and the negative 2. I'm going to bring them both over the equal sign. So I'm going to get minus 2x plus 2 is equal to 0. Okay. We're going to get a brain break, I promise. Okay, so now I've got x squared, and then over here I've got minus 4x minus 2x. This is going to give me minus 6x. And then I've got negative 21 plus 2, and that's going to give me minus 19 is equal to 0. And I cannot for the life of me see how we could possibly we could not possibly factorize this at all. And the reason I can say that is because 19 is a prime number and we're not going to be able to factorize this. Okay, so at this point, guys, I want us to write here, cannot factorize. Okay, I know you could possibly use the quadratic formula, but we do not learn about the quadratic formula until grade 11. So we're not going to carry on from this point on. All right, so we're going to stop this question here because we cannot factorize this. Mateo says no solution. No, Mateo, there is a solution. There is a solution. It's just that we cannot factorize to find the solution. Okay, and the reason why I'm saying factorize is because there's an x squared here. Okay, there is a solution. You learn about it in grade 11, but for now, you don't have to go any further. Okay, that's a grade 11 problem, not a grade 10 problem. Okay. Yes, Namaga.
Sorry, ma'am. So in a test or in an exam, if we were to land up with something like this, not exactly like this, and we were able to factorize it, would it be wrong if we were to leave it like this and unfactorized?
No, you would get your marks. Okay.
Okay.
You would. Yeah. Because in grade 10, they should give you something that's factorizable. Okay.
Ooh, okay. Clear. Thank you.
All right. Relevo, I see you saying, ma'am, how did you get 4x here? I took the negative 7x plus 3x and it gave me negative 4x. All right. I hope that makes sense. All right. I want us to go to our brain break. And the reason why I want us to go to our brain break is because we need to look at simultaneous equations and we're running out of time. All right. Here is our first brain break. Do you guys remember how to do a math 24 question? Does anybody, or for those of you who have never seen one before, Okay, we're going to take all of these numbers and we're going to try and get them to have us make 24. Nomaza, do you have the answer for me? Seeing your
Ma'am,
hand
I've
up.
got the answer for the first square on the left. So
Okay, yes.
I said 8 plus 2 is equal to 10.
Okay.
And then after that, I said 6 times 2 is equal to 12. Then after that, I added those two baddies up and I got to 24.
That's it. Well done. Yo, that one was too easy. That's why there's only one dot. But absolutely, you've got this one. Then 6 times 2 is equal to
12.
12. Oh, we can't. We need 20.
No. Oh my gosh, it's 22.
No, we need 24, not 22. Okay.
Oh
Go
my
back to
gosh.
the drawing board.
Yeah.
Go back to the drawing board. Okay. For those of you who are still a little confused, like what's happening here? Guys, we need to take all of these numbers in the one square, add, subtract, divide, multiply, and give me 24 out as an answer. Okay. Ndumuluka says the second one, 5 times 4 and 2 plus 2. Okay, this one is quite easy. Yes, you're quite correct. 5 times 4 is 20, plus 2 is 22, plus 2 is 24. So this one is equal to 24. Okay, this one is also as easy. See if you can figure this one out. It's quite easy. It's not that difficult. Okay. All right. Nomaza, do you think you've got it now?
Girl, I don't think so.
No?
Maybe. Because like I was trying to work this one out where I was like 8 times 2, right? That gave me 16. And then I would add, if I'm not mistaken, 2, which is also going to give me 18, but then it doesn't give me 24.
Yes.
That's the sad part.
16 plus 2 is 18. What about 18 plus 6? How much is 18 plus 6?
Girl.
It's 24, girl. You've got the right answer.
Oh, ma'am, it's been such a long day. I'm so sorry. My math is so slow.
Okay, I'll excuse you. It's a Monday.
Today we had to rewrite
But
a
this
math
is
test.
right there. It's right there. You did
No.
it. You did it. You did it. It's not that bad. It's not that bad. Okay, and you see, Bonolo also has a different answer. Unami has a different answer. Guys, it's that simple.
No, ma'am. It's been such a long day. I'm just not okay.
Oh, I'm sorry, my sweetie. I'm sorry. But there, you figured it out. It's not that difficult. You see?
You know,
It's
end of the
not.
day, I'm at Johannes Goldberg.
It's okay, my sweetie. I think Ria Leboga might have a different way to do this one because I found a different way. Ria Leboga, what have you figured out?
Hi, ma'am.
Hello, my sweetie.
I got the 8 times 2 is 16, and then the 2 plus 6 is 8. And then you
Good,
add
yes.
the both.
We can, and then we add them together. So we can take
Yes.
6 plus 2 is 8, and then 16 plus 8. 16 plus 8.
24.
Oh, sorry. 16 plus 8 is equal to 24. You see, it's okay. It's okay. It's not that bad. You see that, Ria Leboga? I gave you guys easy ones. All right. Thanks, Ria Leboga. Awesome stuff. Okay. All right. For those of you who want to practice some more, I'm going to take you guys up top here. I want everyone to screenshot number 2. Take a screenshot of this. Okay. This is the question we're going to get on Wednesday, as I'll try this when we come in. So I want you guys to go and try this one, take a screenshot or write it down. And we're going to have a quick look at it when we come together on Wednesday. Hi, Ntumbuluko, what's up?
Ma'am, I found the answer for number 2. Can I say it as I wait till Wednesday?
For this next, for the other brain break, for the other maths 24, or for this one?
Yes, ma'am.
Oh, dude, can I ask you to wait until next week? Okay.
Yes, ma'am.
I just need everybody else to catch up to you because you're really good, my dude. Well done.
Okay, ma'am.
Awesome, thank you. I'm gonna call on you, so you need to come to class early next week. Okay, you need to be the first person in my chat. All right, okay. We need to learn very quickly about simultaneous equations. Okay, how many of you guys have heard, just give me with a yes or a no in the chat. How many of you guys have heard of simultaneous equations before? Yes or no? Klinga says yes, excellent. I'm seeing no, yes, yes, yes. Stacy says I don't know what I is. Itumeleng's heard of them, Nobuche has not, Palisa, yes, Maria, no, Keisha, yes. Adelaide's like, nah. Okay, cool. Unati says no. Itumeleng's heard of them, I love this. Karen says no. Vaughn started them today. Oh, you guys, see, I'm trying to keep up with your teachers. And Dave was like, what's that? Okay, relax. You're going to be fine. Don't worry. We're going to talk through it. All right. I'm seeing quite a lot of no's. It's okay. We're going to talk through it really quickly. All right. So the word simultaneous, guys, the word simultaneous literally means at the same time. Okay. It means at the same time. So what we're essentially doing when we are solving for simultaneous equations is we're solving for two things at the same time. Now, I want you guys to look at these two equations I've written here. Okay, this is equation 1 and equation 2. Okay, there's a problem with me having to solve for anything here because I have two unknowns. What are my two unknowns, guys? What are my two unknowns? Yes, Itumeleng.
Ma'am, is it X and Y?
That's it. It's X and Y. Good. So I can't solve. If I say to you, Itumeleng, what's the answer for X? You can't tell me because you don't know what Y is, right? And if I asked you, what's the answer for Y? You can't tell me because you don't know what X is. Okay, but they have given us two equations. So we're going to use both of these equations to calculate for X and Y at the same time. So that's what we're going to do. We're going to figure out what Y and X is together at the same time. Now, there are two ways that we can do this. There's one way called substitution, and there's another way called elimination. Now, I'm going to start with substitution because this is the easier one to do, right? So I'm going to leverage the idea. Okay. Michael, I promise you, it's in your book. It is. Okay, it is in your book. All right, I'm going to start with substitution because it's the easiest. Okay, so I'm going to look at equation 1, guys, and I'm going to notice that over here, there's a y. And this y is actually equal to x plus 4. So I'm going to then look at equation 2. And in this equation, wherever I see y, I'm going to replace y with the answer. Okay, I'm going to replace y with the answer for y. So, answer with an E, answer Ray. Okay, there you go. It's the answer, right? So I see that in my equation 2, there's a y over here. And I know that my y is actually equal to x plus 4. So I'm going to go to where my y is, and I'm going to replace that y with x plus 4. But I need to do it in a way that makes mathematical sense, in a way that my teacher can read. Okay, so I'm going to write here. I'm going to start by going, that's the first thing I'm going to do. Let y is equal to x plus 4 be equation 1. Okay, it's very important that we do this so that they know what we're doing in the next couple of steps. Okay, and then I'm going to go y is equal to negative 2x plus 1. And that's going to be my equation 2. And then what I'm going to do next is I'm going to write this. I'm going to say, I'm going to take equation 1. Oh, let me do this. I'm going to substitute. So I'm going to write sub for substitute, sub equation 1 into equation 2. So I'm going to take this y that I have for equation 2, and I'm going to replace it with the answer that I have for equation 1. So where I see the y, my y is no longer y. I'm going to write here x plus 4 is equal to negative 2x plus 1. And now can I solve for x? I can solve for x, right? This is so much easier because I've already got an answer kind of sort of put together. Okay. So I can now solve for x. I'm going to take everything with an x over to one side and everything without an x over to the other side. So I'm going to end up with x plus 2x, because negative 2x goes over and becomes plus. And then I'm going to take the 4 over and it'll become negative. So I'm going to get 1 minus 4. All right. And I see Rianette's hand is up. Rianette, what's up? No. Rianette is not unmuting. Okay, Nomaza, do you have a question for me, my sweetie?
Yo, girl, I've got about like 5 million.
Okay, all right.
But-
Take it slowly. Take it easy on me.
Okay. So what happened to the y?
Okay, remember we said that we're going to replace y with what y is equal to. All right.
Okay,
So
okay.
yeah. So in the next equation, wherever I see a y, I'm going to replace it with x plus 4. And over
Okay.
here, first thing I came up across with was a y. So wherever
Yes,
I saw a y, I replaced it with x plus 4.
Yo, ma'am, because I was side-eyeing it so bad. I was like, what is going on here? It was not make sure for like 5 seconds.
That's okay. That's okay. And now you see where I'm going with the answer that I've got. Yes?
Yes, ma'am. Yes,
Okay.
now it's making sure. Yo, because like, no, like, ma'am, I was so stressed. I was like, is there something wrong with me?
No, it's not that bad. It's a substitution.
Am I dying?
No, we're substituting where the y is x plus 4. But
Okay,
you
so
got
wait,
it
like,
right.
quickly before you mute me, quick, before
Yes.
time runs out as well. So what you did was, you said, let y equal to question thingy. What?
Yes. Okay,
Yes.
so first thing I did
You
is I
said
took
replace-
both my equations and I numbered
Mhm.
them. Okay, it's
Yes,
very
ma'am.
important that you number them. So I took the first equation that I had and I said, let y equal x plus 4 be equation 1. Do you see how
One.
here?
Okay.
Mhm.
Yes, I'm with you.
I took the next one and I said y is equal to negative 2x plus 1 be equation 2. Do you see that?
Okay.
Mhm. And the
Okay.
reason why I'm doing that is so that I can write this step over here, the one where I use sub.
Yes,
Sub-
not the star. Mhm.
Substitute 1 into 2. Okay, so
Okay.
whenever I see a y, I'm going to replace it with x plus 4. So in this first equation over here, in the second equation, I saw
Yes,
a y.
ma'am.
So I took the y and I replaced it with x plus 4. And that's where I got x plus 4 is equal to negative 2x plus 1.
Yes, ma'am. Okay.
Okay.
Yeah. Oh, okay. Oh my gosh. Now I see you. Oh my god.
Okay. And that's all I did. I just said, where did I see a y? And wherever I saw a y in the second equation, I replaced
Okay.
it with x plus 4.
Oh my gosh. Yo.
And then I can just solve for x because it's not that deep. Okay.
Yeah.
Nice question. That was an excellent question, Namaza. Thanks so much, my sweetie. Kumo, you've left me, and I was hoping you would ask one last question before we go. Does anybody have an answer for x for me? That's it. Yes. Lesego says, ma'am, is the final answer -1? Yes, it is -1 because this is 3x and this becomes -3. And then I divide by 3 on both sides. Therefore, x is equal to -1. Stacy's like, it's very deep. Don't worry, Stacy. I'm not going to leave you in the trenches. I promise. We're going to come back and do this. But guys, don't forget, I'm not finished. I'm not finished. Because remember, guys, we were solving for x and y. So now that I've got an answer for x, I can now take my answer for x and plug it back into my formula. It doesn't matter which one. Okay, I'm going to choose equation 1 because it's easier. Now that I have an answer for x, my x is -1. I'm going to go back to that formula and I'm going to go y is equal to, wherever I see an x, I'm going to replace it with -1. So my x is -1. So I'm going to go -1 plus 4. Therefore, don't forget my therefore, y is equal to 3. Okay. What I want you guys to do for me, I want teacher Nels to run the poll for me, please. And then I want you guys to screenshot this and go have a look at it again.